Let's start the show, gentlemen. We got lots to talk about. We're going to take you up into the cosmos again on a Monday morning. It is time once again, folks, for a special vlog on Mondays, 11 to noon. We call the SBAU Astro Hour on behalf of our Santa Barbara Area Local Astronomy and Telescope Club, SB's Astronomical Unit, South Coast Central Coast Longtime Club, 1955 we were started. We're based at the Museum of Natural History up in Mission Canyon, where SBAU holds our first Friday of the month general meetings at 7:30 p.m., hosts the very popular outdoor star parties like one this past weekend, starting at dark right next to the Palmer Observatory on the second Saturday. If you're interested in astronomy, folks, come join us and tell your friends about our Monday morning get-together. This is number 152 we're doing. When we hit March, we will start our fourth year of SBAU Astro Hours. I'm your host, Vice President, newly reelected, Ron Herron. I'm going to introduce you to the crowd here in a minute, the gang, what I call the Brain Trust. Here's what we're going to be talking about on this Monday, the 15th of January, which runs through Sunday next weekend, the 21st, and Friday we go out to Westmont. But here are the headlines. This is what our subject matter is today. We're going to explore some Maria on the moon and some craters, at least one up there. It's waxing. We're going to check on a couple of comets. What is it, 12P or 19P? I can't even read, 72, something P, Pons Brooks, can't read my own writing.
12.
Which one is it, gentlemen?
12.
12, and it's, okay, that's a one then, the 12P, Pons Brooks. And then the other one, if you can lump them together, because they're separate in your talking points, Jerry, 62P, Suchinshan, I think it's called. Asteroid 3, Juno, is southwest of Sigma Leonis. Use your binoculars if you want. The morning stars, Venus and Mercury. Mars is back. Big masses of Earth are on the Earth, under the Pacific and under Africa, about the size of the moon. What the hell is that about? We're going to talk about it. And have you ever wondered about the planetary poles, folks? The axis around which a planet rotates? We're going to look into that today on the Astro Hour. Let's meet him. Newly elected, our beloved president, Jerry Wilson. Mr. Knowledgeable, he's on his cell phone talking to something, so wave at us, okay? He's married to Pat Forgy, who is also a longtime member and an ardent supporter. Chuck McPartland and his wife, Pat. Chuck is there in front of the Ukrainian flag. An incredible outreach. As far as I'm concerned, he and Pat McPartland, who has the word parsnip in her email address, are the heart of the club. Merchandise manager, and she's now treasurer. Chuck is outreach 200 times a year. Tom Whittemore is with us, his wife Maureen. Tom, thank you for your job on the newsletter. I assume you're enjoying retirement from the lab out at Westmont, where he was an incredible science teacher. Bruce Murdoch is sort of wave at us, longtime supporter, telescope enthusiast, president of the Santa Barbara Theater Organ Society, and his wife is Bonnie. And son of a gun, if there isn't Tim Crawford, who's waving at us. Are you the one with the real name Tom?
Yep.
Okay, you're Tom Crawford, but you know, I got a friend that I meet with on Thursdays who does the same thing. There's too many Toms or Tims. He's called Tim, so his real name is Tom. Wow, you should meet him. Tim
That's
Gracie.
cool.
Yeah, he's an old sheriff's deputy, retired, named Tim Gracie. You're a resident lens and telescope expert, and you're married to Karen. I've done the headlines. Now we're going to do the silly stuff. These are President Jerry's forwarded to all of us during the week, silly science cartoons. I haven't perused my comments here, so I hope I can match them as you bring them up, Jerry. He's trying to get us on YouTube, and I'm not sure if we're going to be seen live by that vast crowd that hangs on to our every words every week.
Well, they're actually half-vast.
Okay, I love it. We do have a lot of fun, and I learned so much, folks. I'd like you to tell your friends. And sitting out there in the dark and the cold Saturday night, I was spreading the word about our meetings and joining the club, and I think maybe we might want to just launch a campaign. Could start right here. Jerry, are we anywhere close to solving the YouTube problem? You want to go ahead and bring up the silly cartoons?
Looks
Have a
like
little
he's
levity
busy.
start off. I wish we could broadcast to you what we were talking about for the 15 or so minutes before we start the show, the stuff we talk about, jury duty and God knows what else.
We're talking about alternate names, Tim versus Tom. My wife's ex-husband's name is Mike, and there's so many Mikes that he went by Zeke.
Oh, Zeke. What is Zeke short for? Ezekiel?
Nothing.
I think Zeke is short for something.
Okay, did someone call my name? Mike?
No, I
Okay,
Brother-
we're still working on live stream. It's more involved. So I'm gonna start the
the silly stuff, the silly science cartoons.
yeah, just a second here. I gotta get
Should realize,
things at full
Mr. President, if you
screen.
change units, go to a new laptop, it's gonna throw everything into a tizzy.
It sure does.
'Cause they are
Well,
less
it was his
forgiving.
desktop that is not working, right?
The my desktop computer just simply ran out of it doesn't work. So
I can take a look at that if you'd like.
no, you're my backup.
All right.
It's interesting. We're showing that there are 7 participants.
I think you got 2 Bruces.
Right. I have you on my cell phone, which has the audio and the video, which I'm looking at right now. And then on my big screen, I'm also on there so I can see things that aren't a little tiny.
Well, you use a PC, big computer
Right. It's a
components.
big PC.
Well, maybe if you bought a laptop, they're only $400. Oh, there you go. Okay, that's it. But it doesn't have, it must be an older model.
This is one I built, and it has parts that date back. Some parts date back to 2009.
So the moon's
it's-
waxing and it's about
As I
to,
improve it, you
okay, here
put
we
new
go.
things in.
All
Like
right,
it's
here we
got all
go. This
solid-state hard drives.
statement for the ages. Every mathematician, there's a fine line, between a numerator and a denominator, and doggone, only a fraction of the people will find this funny. I guess
Yeah.
that fraction. Here's how Alaska
I like
Airlines
that
solved the
one.
problem with the door. What do they call them? Door stubs, door dumps, door. There's a new word.
The plug door.
Door plug. I knew it was something with 4 letters.
Yeah, I love this one.
Yeah. Duct tape
There's-
are us.
Industrial
surprised
duct
that
tape.
I'm surprised that the door was designed that way because the main doors on the cabin pressure pushes them harder against the seal, trying to push them out and they can't.
Yeah.
But this thing is the other way around.
Yeah, I was surprised by that too. And it's held in by 4 bolts that apparently weren't attached.
Well, I think it actually is the same design, but it has it's designed so that you lift it out. And so there's a bunch of channels that it comes down into, and then it gets
Okay.
pushed out. But the bolts are supposed to hold it from moving up in those channels. And I think if you get turbulence and stuff and the bolts aren't in tight, it can actually move up a little bit in those channels and then it can get pushed out.
Yeah. Well, obviously that happened.
Yep.
Yeah.
Along
Okay.
with shirts and shoes being sucked out. All right, you're gonna have to raise that up a little bit. I don't recall getting this one. I don't write anything, but there's a man and a woman, I assume astronomers, or they people that come to our star parties looking into, they're not looking into the, what,
haven't seen
tell
that
me
one
about
either.
this.
It's
What
a
is it?
photo they're looking at.
Oh, it's a picture and.
Yeah.
he's
And
telling
behind them
you're-
is a telescope like the one at Mount Wilson there.
Yeah.
That
It
will
looks
have
like the
our-
100-inch hooker.
That's somewhere between a nova and a supernova, probably a pretty good nova. Okay, not bad. These days they're warmer in those observatories, aren't they? They look in computers and other.
Even
rooms.
my wife got this one.
Okay, you got to be a mathematician to know about grids and y-axis and x-axis. How happy astronomers are. The happier they are, how far away the new supernova is.
If you're too close, you get burned up.
The further
But if
away.
you're too close,
Yeah.
Yeah,
Okay.
they get unhappy.
Well, the little orbiting galaxies around us, what do they call our little family? Are we the
Magellanic
Virgo
clouds.
family? Okay.
The
Fascinating.
local group.
Local group, that's what the word is. All right.
But they're not all orbiting us, those.
I don't remember getting this one. This is new, so here it is. And you're gonna have to reduce it or move it up because I can read one line. For God's
Superman,
sake.
but something else.
All right, Superman is running past the lighthouse, and these 2 gentlemen are inside it, and one says to the other, looking at Superman fly by, for God's sakes, kill the lights, Murray. He's back again. Okay.
I don't get the connection.
He's a moth.
Like
He's
a
like a
moth.
moth.
Oh, okay. Yes,
Let's
yes,
do that.
yes.
Yeah, get those fly swatter out. Okay, and now we have a large blob of dark matter in a psychiatrist's office, spilling its emotional guts out, often questioning, let's see here. They all ask, what is dark matter, Doc? And where is dark matter? But nobody asks, how is dark matter? We know, don't we? Dark matters.
His feelings are hurt.
Yes, that's right. I have one of those limited edition bumper stickers. I wonder how many of you guys got one. All right, way back 65 million years ago, two dinosaurs, as the killer asteroid comes in, saying to each other, so no matter how bad things may look, guy, you just have to say to yourself, hey, it's not the end of the world, for crying out loud. Boom. Yes, iridium for everybody. Good
6
stuff.
mile wide asteroid.
Most of our silly science astronomical cartoons take place here on Earth.
Can I interrupt just for a second, Jerry? Chuck
You just
Watson.
did.
Chuck Watson has texted me. Is the show canceled? Are you going to continue to try to log on to YouTube?
He probably ain't gonna hook up. Why don't you just text him back? Our apologies.
Yeah, I will. I'll text him back that we're working on it.
Sorry
I
about
have
that.
2 computers that are logged on to YouTube, so it works, obviously.
Yeah. Okay. He's trying. I can tell. He's up close to the screen. That's off his beard, but that's all right. And where are we here? We're back.
Jerry's gone.
Gary is not back. Were you guys
He was
going to
up.
talk about the moon or the craters or Venus and Mars or anything while he's gone?
I think he'll
Already
be back
another
pretty
hour.
quick.
All right.
There he is.
Jerry, can you hear us? Can we hear you?
I'm back. I'm back.
All right. We're not going to get any YouTube viewership today, are we? This 150-second program, July 15th to the 21st, started screen sharing. What does that mean? Oh, we're about to throw stuff up. The sky, please. Could we have the sky? We always start with the sky, the night sky, without pollution.
It says my internet connection is unstable. So this
Oh, here-
might be a good time for Chuck to get ready to carry
the-
on if I
Can
go
you-
blank again.
Can you
Okay.
increase the size of this just a bit? This is the weather system as portrayed by a child with a crayon in preschool. Big weather system coming through. Here's what we know so far. You got atmospheric rivers, Pineapple Express, polar vortex, and it's everywhere. And we're pretty lucky here, aren't we?
Yeah, they know nothing. Okay, that's that.
Gotcha. That's our sillies. Never a dull moment in astronomy. I got to tell you, we had a good crowd though. Saturday night, 300 plus, or almost
Oh,
300.
good.
236.
236, almost. All right, we're getting there. And what's happening in the future, Mr. Outreach Chuck? Friday?
Tomorrow night is Mountain View School, probably going to be cloudy. Thursday night is San Ynez Elementary School, probably going to be cloudy. And Friday is Westmont. We'll see. We'll see.
Right. And right now it's cloudy.
Yeah.
A little sun coming through. Okay, where are we here in the sky?
Okay, this is
You
a
never know
McPartland
from this
Memorial
finder chart.
chart.
You were
This
saying?
is this has got a double whammy. It's the graphics that Chuck doesn't like. But I didn't want to reproduce this line on the real one, but we'll get to that in a minute. And this shows Deneb and Cygnus, which is right on the horizon, just about to set. So it's a last minute look. These really faint objects, the North American Nebula and the Veil Nebula are shown here. And you're right, these charts are hard to read. But anyway, this is Comet Pons Brooks currently during the month of January. Here we are at the 15th with NGC 688 just passed. That I believe is the Crescent Nebula.
It is. It is.
And so
There was
that
a great
is-
picture on space weather of the comet going right by the Crescent Nebula.
Yeah, this one
Yeah, there you go.
taken by Damian Peach.
Oh, wow. Okay.
Well,
This is
where
a
on that?
picture of the Crescent Nebula taken by Jerry Wilson.
Right on.
Really? All right, Jerry.
And this is a readable chart. Here is Cygnus, and this is 6 p.m. at night, which it's not really this dark here now anymore. So, and the comet,
Right about in the middle.
yeah, there, Crescent Nebula, right there. So it's right in this region here.
Okay,
And this shows the North American Nebula up here. And it doesn't really show the, probably this or this, probably this is the Veil Nebula. Oh
I
no,
don't,
Veil Nebula is over here. I got it.
yeah,
in
yeah,
the
yeah.
wrong wing pit. So, okay.
and that's, can you, is there any way, Mr. President, you can lump this together with the other one, the Chuchinshan 62P?
That's what I wanted to avoid. That takes a lot of time because this is in Photoshop. No, this is in the Sky X or the Sky
Okay.
6, one of the skies. And
Okay,
it's
they're not-
difficult to draw lines on it. Like
Okay,
that.
but, so we're gonna talk about other things and then get back to the other comment at the end?
Yeah, we're gonna get it back to Tsushin then
Okay, got it.
Tsushin later.
Which is
This is
Chinese,
Pons Brooks.
right, okay,
And Pons Brooks, I believe, is right now, it's not visible to the naked eye. It's magnitude 8.8, but it's slowly brightening. And it is recommended by Astronomy Magazine that you use an O3 filter.
Oh, interesting.
It
Yeah.
also was undergoing outbursts every 15 days. Because it seems to have a cryovolcano on its surface.
Yeah,
So it was doing it, it did it once, did it 15 days later, and then everybody said, okay, get ready, it's about to do it again, and it didn't happen.
okay.
But now we're 15 days past that. So once again, they're saying, well, look, it might happen.
No, I think if it failed once, it'll fail systematically now.
what, is it fair to say, gentlemen, that most comets are relatively small rocks, a few 100 feet across, but they emanate enough stuff to, we can see it because it becomes the size of like a planet?
Yeah.
We see it because it's bright.
Okay, but there's enough stuff to reflect back and it's as big
Yeah.
as the planet across the, if not bigger. I wonder
Well,
how-
it ends up not being a lot of stuff, actually. I heard an analysis once for Comet Hale-Bopp, which had the huge tail, was that
Okay.
if you managed to take all those particles, you could fit them into a good sized suitcase.
Oh, geez.
Whoa.
Okay, but they spread across many, many thousands of what, kilometers,
Yeah,
miles?
millions of miles, some of them.
Yeah, yeah. You'd never get through the TSA screening, but with that suitcase.
Yeah.
Can we see stars through those tails?
Oh
Yes.
yeah, you can see stars right there. See those? You can see my cursor.
Yeah,
Yeah, see there's
Star.
stars right through the tail there.
is the tail going straight up?
Yeah.
Tail's going up this way.
And that's how it looks. So you can,
Yeah.
we could say the sun is to the bottom of the photograph, the other direction.
Yeah.
Okay,
Yeah, roughly, yeah.
And that Crescent Nebula up there, it kind of does look like Van Gogh's ear.
Yep.
huh.
Okay.
That goes here.
That's
Okay.
another name for it, Ron.
That's another
Is
name
it?
for it, yeah.
Well, I always wondered what his ear looked like, what happened to it.
Yeah.
Okay, now this is the third rock from Mars. It is
Okay, which-
Juno right there in the middle. And this is about 1 a.m. tomorrow night.
Okay,
And you can see this is the Virgo cluster up here, which will be in the evening sky in another 2 months. So this is the start of the period when you can look out of the North Pole of our galaxy. So the
North
Milky
Pole of
Way
our-
in our skies is going to lay down flat along the horizon, and we're going to be looking out into intergalactic space. It's a good time to take pictures or observe galaxies.
Did you make?
Line flat or be about 34 degrees off the horizon?
What's that?
I say, you said it'll lay flat on the horizon. Won't it be like 34 degrees elevation?
No, in May, the Milky Way goes right around the horizon.
Yeah.
Oh, really? Okay. Oh, yeah, of course, of course.
But did you
Okay.
say a North Pole of the universe?
North Pole of the galaxy.
Yeah.
Oh.
I don't think the universe has a North Pole.
But the galaxy does.
Yeah, it's
Yeah.
up there in Coma Berenices, which is that kind of smattering of stars just to the right of the clock up there.
Okay, that would be above the bar in the middle where the big Sagittarius A is.
No,
I know
No.
that it's
This
not the
right.
north. Our North Star is above our pole of the
yeah,
planet.
yeah.
That's right.
Okay,
No,
but
the galactic pole is not marked by any particular star that I know of.
oh, this is the first time I've heard of a pole for the galaxy. Okay,
It's really a crowd effect.
can we see the South Pole?
Yes, from the
Mhm.
southern hemisphere.
Right.
Okay,
Now, this is these are 4 different pictures of asteroid Juno taken by the 100-inch Hooker telescope on Mount Wilson in 2003, excuse me, in 4 different wavelengths here. The 934 would be closest to infrared. They're not true infrared. 500 nanometers, that's in the middle of our visible spectrum. That's round greenish color. 700 is a little more toward orange, yellow, reddish. And then the 833 is in the red. 620, I think, is the hydrogen alpha for hydrogen, which is definitely red. So these are the 2 bottom one, 833 and 934, are in what we call the NIR, or the near infrared. And most of our cameras that we use for amateur telescope or for amateur pictures cut off just short of 1,000 nanometers at 1 micron.
okay. The nanometers measures light or distance?
Measures the wavelength of light.
Wavelengths of light.
If you're calibrated like I was in angstroms, which is sort of like memorizing everything in imperial units, this would be 5,000 angstroms.
Right.
Or 0.5 microns.
Ron, I just did a quick look up, and the South Galactic Pole does come above our horizon in Sculptor.
Is what, Sculptor?
Yeah.
Okay.
Huh. Okay. So we can't count individual photons, even though they're kind of delineated as separate things,
You
awfully
can count
small.
them. You can count
Yeah, we
them.
count them.
How many, let's say 500 nanometers, upper left picture. How many photons is that? Just jillions?
No,
That's a wavelength of the light.
That's the wavelength.
Yeah, it's the amount of energy in a single photon.
It's not the distance between the light waves.
Yeah, it is. It's the distance between repetitive peaks of the light wave, crest of the wave.
I got you. And that's how they it doesn't look like the same asteroid to me.
It's rotating.
Oh, is that what it is? Oh, okay, there you go. And this is going to occult something, or we can just see it?
You just see it.
It's named after Jupiter?
No.
Jupiter's wife, Jupiter's sister.
Yeah.
Well, we have a probe going around Jupiter named Juno.
Yeah.
Okay, just happens to be, fascinating
Well,
stuff.
the reason the Juno probe is named that is because he was always fooling around, and his wife Juno had a magic pool that she could look into and see what he was up to, like a magic mirror. And so that's what they did for the Juno probe, was they're going to look into its atmosphere, and so it was named Juno.
So Juno was married to Jupiter, and Jupiter was a legendary king?
Well, he was the main god of the Roman
God.
pantheon.
Okay. Didn't know gods had wives.
Here's the brains of the outfit.
Princess.
Bring on the kitties. Okay, we're now on the moon, waxing
Okay,
moon.
now we're in a sweet spot of the moon, just leaving it because of looking at galaxies and stuff. We want no moon. The moon just passed new moon last week, late last week. It's headed for the first quarter in a few nights here. I think Wednesday or Thursday it'll be first quarter. But it's a good time to look at some stuff on this moon surface. And visible in the current phase is Theophilus, Cyrillus, Katharina, and Torricelli. Sounds like a ragu sauce.
That
But these
Okay.
show, you can see on here, you can see compression ridges where things, when they expanded or flowed, they made a wave or an upwelling, like when two ice flows run into each other, they make a pressure ridge up there. This is that kind of stuff. You can see the blast from Theophilus going out from these things when they hit. There's a nice central peak here, which when something heavy hits the moon like this, there is so much kinetic energy involved. It's just way, way up there that the kinetic energy melts both the incoming object and a certain portion of what it's hitting. And so for an instant, for a short time in there, it acts like liquid. And that's when these features set, and then it refreezes before it can really flatten out and stuff. So that's why you get this central peak. It's the rebound of the
Right.
of
Second
the
thing,
forces
same
coming
thing
in.
happens in water, doesn't it? When
Yes, except the water doesn't freeze mid
right, all right. Well,
impact.
cold enough it might, depending where you live, I guess.
Mhm.
Theophilus, okay. Flows of lava now, lunar sea, there's a bay of, what's the name of the bay? Bay of,
There's all kinds of bays.
so there's a Sea of Tranquility is nearby, right?
Yep.
And something called Sinus Asperitas. Am I right? No, Asteropatus. Oh, the Bay of Roughness. Is that in this, or is that the next picture? Just quoting your
Oh.
talking points, Jerry, the Bay of
The
Roughness.
talking points, this is a neat picture of stuff to see. The next one is the talking points address this.
Oh, I'm sorry. Okay.
That's okay.
But
And
okay.
the white dot you see here, right there, that's the Apollo 13 landing spot. Now, Apollo 13 didn't land on the moon. They had an issue on the way, and they decided to bail.
Right.
But that was the spot they were headed for, and I believe Apollo 14 landed in that region in 71. And this is called Frey Maro, Brother Maro Highlands.
Huh.
It's a mountainous massif near Mare Imbrium.
And that's where they were getting a little braver and heading away from some of the smoother areas.
Yeah. Even though it looks rough on this scale, it was quite doable once you got up close to it.
There's some rolling hills. They're not exactly craggy mountains.
Mm-hmm. And my talking points in this one and another one later were translated from French. So they don't read real well, in my view. They're a little clunky.
Did you do the translating?
I didn't do the translating. The machine, you know, these computers will translate anything for you. If it's on Facebook, for example, which this was. This is from a guy who's very prolific and does excellent work named Robert Cazellac in France. He's a Facebook buddy of mine, a Facebook friend.
Huh. Well, you just used the term, Jerry, Maro, M-A-R-O, which has got to be a takeoff on Mare.
No, Ron. It's M-A-U-R-O. It's a guy's name.
Yeah.
Oh, I see. So these are Mares. And
well, it's the name of a crater.
Yeah.
Okay, but aren't Mares the same as seas? The big
the Mare, these flat regions out here.
Okay.
That's the sea. That's the Mare. This is the highlands, the mountains overlooking the sea.
Oh.
So this is where you'd build if you wanted to be on the shoreline.
Yeah.
Wow. Wouldn't they be taking a chance trying to land there? They might hit a side view or a slope.
One of the very first landings on the moon, didn't Alan Shep, I forgot who the astronauts were.
Yeah.
Flew it by hand to avoid rocks and things.
That was the very first landing. That was Neil Armstrong.
Right.
Yeah.
That was Tranquility.
And that was where they learned they had the ability to avoid things.
But now the plural of Mare would be like you spell Maria, but Maria, because that's the word you came up with, Maria. Is that plural?
Maria, yes.
Yeah, Maria.
Okay. And then Morrow is a person. Got it. For the exam later.
So the plural of Morrow is Morrow.
Got it. 2 Morrows.
Okay. Now,
All
the
right.
first
There's a song about
amateur
that.
photographed supernova of 2024 is in NGC 4216, which is up here in the Virgo cluster.
Mhm.
It's not shown by a dot, but I put the cursor there where that galaxy is. And this again is an amateur photograph. And again, it's down here, you can see Robert Kazalak, 2024. So he does a lot of imaging. Some of it's very good. And so I put it on the website here.
Mhm.
This was taken on
January 4th.
January 4th. Thank you. The non-English date things threw me off. So it's believed to be a type 1A. It's at 13.5. So visual magnitude. So you could not reach this in, say, a 6 or an 8-inch telescope visually. You'd need something bigger, like an 18-inch. So this shows the edge of that galaxy in 2020. And now you have this supernova up here. And I think it's better than a pretty good nova. It's a supernova.
Yeah.
But they don't have time, do they, to brighten up the whole galaxy? That takes thousands of years, I guess. So just
I don't know what you mean.
Well, that very spot is where we see sometimes a nova will brighten up a whole nebula around it, but that's only.
Oh yeah, yeah, but we're far enough away that we're not seeing the local structure here. We just see the explosion directly with all the light it's putting out.
Okay.
And
It's a
Ron, I
January.
think you're kind of conflating that a little with the supernova can get brighter than the galaxy.
Yes.
Yeah, I've wondered about that, but it can't obliterate the whole galaxy this soon. The galaxy's hundreds of
Well,
millions.
Yeah, no,
And
no.
and
It just
Ron,
it's
That'll last for a
individually
couple of
brighter
weeks
than the
and then it'll
galaxy.
fade.
Ron,
Okay.
this happened probably about 60 million years ago.
Yeah.
Yeah, right. Yeah, this is
There
definitely
was a similar
passe.
supernova in M82 a couple of years ago. I got a picture of that.
But no,
You
this
do.
one didn't explode on January 4th. That's just when we tuned in and found it.
That's when the light reached us.
Mhm.
Well, that's true, but
Next
okay.
week we'll discuss a light cone.
A light
Okay.
cone.
So we do photograph supernova in galaxies very far away, where the only thing we see is the supernova
Mhm.
because it's brighter than the galaxy.
Is there an average for galaxies, 1 or 2 100 years for every millennium?
Something like that, I think.
That's about what it is for our galaxy, but it depends on the star formation rate you have in the galaxy.
Right.
Okay.
A question for you, Jerry. There was a recent article that I can't remember when it was, but they had spotted a supernova that was really way out there. And I think that they were able to spot it earlier than just the speed of light. Was it gravitational lensing or something that they were?
No,
Can't do it
that doesn't-
faster than the speed of light.
Yeah,
Okay.
but the gravitational lensing magnified it so that you could detect it, whereas otherwise you wouldn't.
Yeah.
Oh, that was what it was. Okay.
A really cool one that happened a couple of years ago was multiple images of the same supernova arriving at different times because of the different light paths going around
Right.
a gravitational lens.
Now that is so cool
Okay.
when that happens.
Yeah.
Okay, now we're moving on to the 2 morning stars, Venus and Mercury.
Mhm.
Now this is late morning, 7 a.m. on my planetarium software. And the sky's definitely darker than I see it at 7 in the morning.
Really?
But you can see Venus here. And there's an asteroid right next to it, Ceres. And here's Mercury down here. So
Yeah, and this was better last week. I mean, Mercury was higher.
yeah.
Yep. On
And
Friday.
Mars is putting along down here too. So
Yeah,
you could
last
probably
Friday-
see these two, if you have a really good eastern horizon, southeast horizon, you could probably see these earlier than 7.
Oh, yeah. At
there's a
7,
little
at 7
given, so
you will
that's-
not see Mercury.
Yeah.
Okay. You'll see Venus easily. I've been looking for Mars. That's been a tough one. It's
Yeah.
been filmy. Been filmy in the
Interesting.
southeast.
You must have had a view of the sky. I just had a view of clouds at 5 in the morning.
Yeah.
Now here we're jumping ahead. This is now January 27th.
Mhm.
So it's next week sometime at 7 a.m. And you see Mercury and Mars are only 17 minutes of an arc apart.
That's pretty good.
They're
Okay.
going to be very close together.
Mhm.
But they're not
What's the
gonna.
altitude there, Jerry? Do you know?
You'd have to guess that. I don't know. It's not very
Not much.
high.
Yeah, it looks like 15 degrees or something.
Yeah, I don't think it'll be that high, but
Okay.
Yeah, you'll need binoculars too.
You ever seen one planet occult another?
sure, yeah.
Mhm.
Has that happened? Really?
Yeah.
Hmm. The
It's
inner
rare.
planets, the inner planets probably occult the outer planets. It doesn't ever go the other way, does it?
As I recall, we had Jupiter and Saturn come real close to each other several
Right.
years ago.
Yeah.
It was last year.
Wow.
Okay.
Okay.
So this is something to look forward to.
Mhm. It'll be tough.
And now we're going to go to a topic that I didn't even know about, and that
Oh,
is planetary poles.
well, we know they have them. Everything spins on an axis.
Yeah, well, they're all over Poland.
Okay. There's Earth, there's Uranus, and there's Venus.
There is something in it. It's counterintuitive in a way. This shows the tilt of the different axes.
Mhm.
This is the Earth tilted at 23.4 degrees. This is Uranus tilted at 97 degrees. And this is Venus tilted at 177.4 degrees. And so you'd think that the North Pole would be the pole down here. But actually, the rotational pole, the angular momentum rotational pole, is what they call a plus pole, the positive pole. So the positive pole of Earth and its North Pole corresponds. The positive pole of Uranus and its North Pole do not correspond. And in Venus, the positive pole and the North Pole do not correspond. So there is something that is called the invariable plane. And north is defined not by a magnetic field like we do on Earth, or we think of it on Earth. It's defined by whether whether the one end of the axis of rotation is above the invariable plane or is below it. And that is a plane that is defined. It's a plane that goes through the whatever it is, the center of mass of the whole solar system. Yeah, I just confused myself again.
But for Uranus, that would be northish.
Northish.
Yeah.
Well, the arrows on the red lines are the turning direction.
Mhm.
And
Yeah.
north
So
is
if
on the
you-
right
if-
in Uranus.
Yeah, so that gives you if you use the right hand rule, which is where you take your hand, you curl your fingers in the direction of the red arrow, then your thumb of your right hand points in the angular momentum axis, and that's the plus axis.
And the north here, Ron, doesn't mean it's pointed toward our north.
Yeah,
It just means it's pointed to the north half of this plane that, divides things to north and south.
mhm.
So it's northish.
But would it be possible to assume that Venus does not tilt as we do, 23 degrees, and it is straight on flat?
No, you can see it's not quite straight up and down. It's
Okay, but
177.4, not 180.
oh, I see.
2.6 degrees
oh,
off.
got it. Right. Okay. So all of them are a little off kilter, Uranus is on its
Oh.
side because something went by it, and we're
Yeah.
23 degrees off because what? The thing that made the moon hit us?
Quite likely.
Yeah, we'll get to that.
Okay.
So anyway, the invariable plane is defined as going through the center of mass of all of the planets, and I don't know if the asteroids are included, but I assume so. And then this arrow points up here, defines the direction of north and south. but this is the angular momentum vector of the entire solar system.
Sure, that makes sense, right?
Yeah,
It's
so
pretty
that
much dominated by the sun, isn't it?
so it's that no, it's not just the sun, it's of the whole solar system, everything.
Yeah, but the sun is like 99% of the mass of the whole universe, of the whole.
Yeah, it's
Milky Way.
weighted heavily, but it still includes all the other stuff.
And again, that's not the north really, that's the plus, but that's defined as north plus for the sun.
They
Right.
just signed the plus, and it's not. If you look at it in space, there's no up or down.
That's right. That's what they're trying to define.
So they're just trying to define north as this plus above
Well,
the plane, this invariable plane.
Yeah,
Yes.
it's more likely, it's more reasonable to call it the plus.
Yeah.
Because it's not, I mean, we define north as where our axis points, but
Yeah.
this is a different northish.
Yeah.
Hey, Tim,
Yeah. Yeah.
you can see that this has its pluses and minuses.
Yeah.
Yeah, I'm a little confused by it, but I'm just going to sit back and enjoy this.
It's reusing nomenclature that probably isn't, quite as accurate as it should be.
As they say, Tom is a card and needs to be dealt with.
That's right. But now, is the north and south pole of
Where
the
did Tom
sun-
go?
What? Is the
Tom
north,
disappeared from my screen.
Oh, he's here. He's waving.
Yeah.
Okay. Huh.
is the north and south pole of the sun the exact same thing as the north and south pole of the whole ecliptic, that solar system? The sun is not tilted in any way.
Well,
So the sun lines up with the ecliptic.
I
Right.
know that, but it's rotating, what, every 22 years or 22
Oh,
days?
no, it has a 22-year cycle, but that's not a rotational cycle.
it's a 33-day rotation on average. Different parts
Depends
rotate
where
at
you
different
look.
rates.
Yeah.
Oh,
Really? The 22 years is black, what do they call them? The dark spots?
It's a magnetic cycle. It's
It's a
sunspot
magnetic
cycle.
cycle.
Oh, okay, gotcha. But otherwise, it's right on target. Okay. And that goes right back to when we were created out of a bunch of gas and dust, right?
Yeah. That's the angular momentum we all had before things started banging into each other internally in the solar system.
But you have planets like Pluto that are a little off the grid a little bit, aren't they?
Well, Pluto's not really a planet. It never really got
Part of the-
into the ecliptic.
Part of the Kuiper belt, which is a big
Yes. It needs
asteroid belt.
a few more billion years of tugging on by Jupiter to get it back into the plane.
Huh.
Okay. I
Okay,
found the
that's-
next one. This one was very surprising to me. I'd never heard of this before. But you can see the north here is above this invariable plane. The north here is above this plane, and the north here is above this plane. So north is defined with respect to this plane. The plus, which we think of as our north pole, is defined by the angular momentum vector. Okay, so that is in summary. Now we're going to look at a geological study of the Earth.
Oh, this is
Begun
heavy.
in the 1980s. This is a cool graphic. These are actually freeze frames from a video. And this shows the surface of the Earth up here. See the continents?
Yeah.
And then the oceans are made to disappear. This is the core of the Earth. And this material, which is iron-like in its mass density, is shown here under the Pacific Ocean.
Right.
And then there's another one. This was the one under the Pacific Ocean. Here's one that's above the core, but it's under the African continent. And so these two things they sort of give a wobulation, you might say, to make up a word from to the Earth, add to our complex motion. And
Wow.
these are remnants of Theia, according to the likely remnants of Theia, which hit the Earth when it was an early star. This was from modeling at, I believe, either MIT or Caltech. Did I say in there?
This is the collision.
Yeah, this is from a collision. And this is the Earth after Theia hit it. And there were their modeling indicates there are two blobs that are primarily Theia bouncing off the Earth's core. And this is the first of those blobs, which is about to hit the Earth, trailing in here with this trailing orbit of goo. Here it's just merging with the Earth. And the second major blob is up here about half a rotation away of the Earth. So one of them is going to end up under the African continent, and one of them down here is going to end up under the Pacific Ocean. And this is the final one heading toward the other site, whichever one hit first.
Oh, that's it. And that has nothing to do with the formation of the moon, does it?
Yes, it
I mean,
does.
it does.
This is the blob at the top there is what's eventually going to form the moon.
There's another blob not in the picture that's even bigger.
There's a third blob that will be the moon. These are the two blobs of Theia that went into the Earth.
Oh,
And this
wow.
is during the collision that formed the moon.
That's really interesting. I've never heard this theory.
Well, I
but
never
it's
did
still-
either.
And
It's still
Theia,
theory, right?
Theia is spelled wrong throughout that article. I don't know where you got it, but there should be an I in
Oh,
there before the A.
I made it up.
Okay.
So
If
Theia
you see
was,
misspelling, it's undoubtedly due to me.
Okay.
Matter of
And-
fact, I was one time congratulated as being a true physicist because I couldn't spell any known English word.
but now, do they think or theorize that Theia was the size of a Mercury or a Mars?
A Mars size.
Yeah.
Mars size hit it, so something like that collides with another body like Earth. There's not going to be a crater. There's going to be what we're looking at here.
Basically,
right.
everything vaporizes.
Yeah.
And apparently the real early solar system was a real shooting gallery. The reason that Venus has such a slow retrograde rotation is believed also due to a planetary collision. And the reason that Uranus is on its side is also hypothesized to be oh, here comes my cat again.
A collision, not a pass by, not a
Collision.
It's a collision. Yeah.
collision. Well, I'm glad I wasn't on the planet back then.
Nobody was.
Nobody, I know. But somehow the moon was not as big. It's half the size of these two blobs that came back, and it somehow got out into a nice round, mostly round orbit. How did it do that? Leaving the angle it did from the collision. How would it get into a circular?
It hit the Earth and splattered stuff in basically a disc around the Earth, rings.
I know,
That
but
over time coalesced into the moon.
I understand that, but why wouldn't it just go on out like a spiral? How does it go from an angle out and then settles into a round?
Some of them,
Conservation of
nonlinear.
angular momentum caused the debris cloud to collapse into a disk, like the rings around Saturn. And then the blobs of stuff within that merged to form the moon.
yeah, Tom, I think the Baron is asking why does the result of the collision not end up in a wildly elliptical orbit around the sun?
Yeah, yes.
Because
Yeah.
gravity is nonlinear. It's inverse square. It sucks.
The two, it's a collision. It's a conserved collision. What's that? Where energy's not lost. It's like billiard balls hitting. The result is the sum. The result is the sum of the two incident objects, and they were close enough to each other that they hit, so they're most likely going to end up in a circular orbit. If something came in from deep space in a hyperbolic orbit and hit the Earth, then you could expect the Earth to be flung out into a wild, weird orbit.
Right, Ron. It was something that was already in an orbit like the other planets. So
But now,
it was
isn't it-
nearly coplanar with the Earth.
Do you suppose it's a crapshoot that something like that would either result in a ball like the moon or a ring like Saturn, or all the rings around those gas planets? Were they result of collisions?
Collisions or tidal disruptions.
Right.
Either or. Interesting.
Yeah.
Okay. We've covered another topic we've never done before. Where are we here now? What?
Now
Yeah.
we're looking at, you remember a while ago, they took the first photograph of a black hole in M78.
Oh,
Well,
yeah,
now-
right.
Now they're looking at M77.
That was M87.
Oh, excuse me, you're right, M87.
Turned out to look very much like the one in our galaxy. They were similar. Globs of orange lit up around the black center,
We don't have a picture like that of the one at our center that I know of.
Yes, we do.
Do we?
Yeah.
Okay.
We had LCO was involved with that, weren't they?
Yeah.
The young man came and talked to us. Is that it? That's the center of the galaxy? That's the black hole?
In
This
another
is-
galaxy.
Yeah,
In
this
another-
is M77, which is another
Oh.
galaxy. And this is a blow up. Let's see, this is a Hubble Space Telescope image of here. ALMA radio telescope array has taken pictures of the region at the very core of the center. And in that, there is this object here, which if you do spectroscopy on it, you can see that it has Doppler shifts of red and blue, which means,
It's turning.
yeah,
It's
red is going away from us, blue is going toward us.
So that's your event horizon, maybe?
No, that's probably the accretion disk.
Yeah,
Yeah.
it's an accretion disk. Yeah, you can't see the event horizon.
Huh.
And this is an artist's rendition of what that data shows. So there would be the black hole with its accretion disk. And this is a spinning accretion disks around it.
Oh, okay, okay.
Except it's spinning clockwise in judging from the Doppler shift in the previous thing.
Yeah.
so it's heated up gas, pretty much gas and dust.
Now this is an active supermassive black hole.
Active.
So, Active means it's absorbing things. It's feeding, stuff's going into the black hole and other stuff is being thrown out because it can't all make it to the exit door. So it's bouncing off.
Right. So an
So-
inactive one would never be able to see. We'd never know it was there if it didn't have an
Well,
accretion.
At our galaxy, it's inactive.
Or
Oh, it is.
relatively inactive.
Yeah, relatively, yeah.
They call
You
it a
could,
star.
you could potentially detect a black hole that wasn't active if it lends something by passing in
Right.
front of it. And so that's what the Ogle program was.
Well, they've given our galaxy's black hole a name like a star, right? Sagittarius A. You guys can't.
Sagittarius
Sagittarius
A
A
star, yes.
star.
Yeah, was that the star that originally collapsed? And
No. Sagittarius A refers to the fact that it's a strong source of X-rays.
Okay, but
Okay, and then
Sagittarius
the star is there because it's a black hole. So it's an asterisk, Sagittarius A asterisk.
Yeah.
well,
That's saying it's a black
yeah,
hole.
and
It isn't a
Sagittarius.
star.
Okay, got it. This is fascinating. Reminds me, Dunkin Donuts is having a sale this.
It
Looks
looks
like a-
amazing to me.
Put that on the list for the planning commission that we serve donuts like Tom Whittemore suggested at our star parties.
Mhm.
Get them day old, they're cheap.
Tom, there was your cheese donut.
Actually,
we
after one astronomy day, when we were out at the big box, Anna's Donuts came out and gave us a big box of donuts.
Oh, really?
Well, they would clean us out with 233 people each getting a donut. Wow, look at this. Is this the other one? This is
This is the other easily obtained comet in the sky. This is
62P.
yes,
Such-
62P
Sushin-san.
Sushin San.
Sushin-san.
Sushin Shan.
Very,
It
very
means
much.
Purple Mountain. It's
And,
the name
yeah,
of their
this is-
observatory there.
We're taking advantage of this is by Adam Block, and he is using this on Facebook to advertise his new process for processing photographs of comets and the background. Because usually when you take it, you have to track on one or the other, and the other one gets streaked. So he has techniques here where he brings out detail in both without the streaking. And he's advertising that. This was taken from his Mount Lemmon Sky Center in Arizona with, gee, I forgot which telescope he used. It's a RC, Ritchie Crescent telescope.
You have a big Paramount mount?
Well, this is a 180 ED. It's a 6-inch refractor he took this with.
Okay. Do they know the size of the rock itself versus that halo that we're looking at? Is that planetary size versus?
No, it's not as big as a planet. I don't
Okay.
know exactly the size of it.
Okay, got it.
And he used two scopes there. One of them's a Cassegrain, that Epsilon.
Mhm.
Okay, are you gonna be
Huh.
able to, are you gonna be able to show us, Jerry, a map of the sky where it is?
No, don't
Okay,
have, I don't think I have one prepared for that. No.
okay.
Was this Tushin? No, this is
That's
Comet
Pons
book.
Brooks.
Yeah. Yeah.
I can call it up real quick here and tell you where it is, but of course can't show you the map.
I assume they're not together. They're in different parts of the sky.
Yeah,
Do you ever get two or three comets in the same area where they almost could collide or look like they're
No,
colliding?
not that I've ever seen.
it's in Virgo, so it's up
Yeah.
kind of in a reasonable hour. I mean, 1 a.m.-ish, 2 a.m.-ish.
Do you suppose all those rocks in the asteroid long ago were like comets and have long since dispensed their stuff that makes the tail, the moisture and?
They probably didn't have as much volatile material just because the sun would have driven it away in the early formation of the solar system.
So they went dry. They got totally dried out by the sun.
Not
Big
totally,
cold-
Yeah.
but not totally, but somewhat compared to comets.
Yeah,
Mhm.
because asteroids don't do this, do they?
Yeah, some of them do.
Some of them make tails?
There are periodically active asteroids.
I'll be damned.
So it's a continuum. It's just like the whole planet and dwarf planet thing.
But it survives, water survives only on the poles. Speaking of poles, like Mars and the moon has water, but only because it never faces the sun. It's down there.
Well,
in
no,
the...
there's plenty of water on Mars, not at the poles. It's just underground.
Oh, that's how it's hidden.
Frozen.
Wow, and it doesn't get forced into.
And there's lots of water on the moon, even where the sun shines, because it's locked mechanically into minerals.
Oh. You'd think it would be spouting, kind of like Io or
No,
some of those
It
ice.
doesn't come, that the stuff that would spout out has spouted out long ago.
Oh, that's okay. Well, that's what I said about the asteroids.
Hmm.
Yeah.
And none
Anyway,
of-
in this picture of this asteroid, you can see very nice picture of a spiral galaxy in the background.
Oh, yeah. At about
Very high definition there. There's a lenticular galaxy here. It is near the Virgo cluster, as Chuck points out. I don't see any other obvious. Oh, there's one there. Yeah, and there's something fuzzy down there. So yeah, there's another little galaxy there too.
Wow.
A lot of detail in there.
Yeah.
Do you suppose, gentlemen, by now the web has shown that there are probably more galaxies out there in the universe than there are stars in an average galaxy?
My impression is it's about a tie.
They're about the same.
It's in the trillions.
Yeah.
Have
It's in
they
the trillions, and most galaxies don't have trillions of stars. So
That's true. There's some big ellipticals that are monsters, aren't they?
By the way, there's a new scam going out on the Facebook claiming that the James Webb Scope has seen city lights on the dark side of a planet 7 trillion miles away. So I responded and said that 7 trillion miles is about 1.1 light year, and the nearest star is 4 light years away. So there is no planet or star at 7 trillion miles away.
That was Proxima, wasn't it?
That's 4.4 light years away, or
Okay,
4
but-
light years away.
I've heard reports that lights are seen on Proxima, the planet going around the small sun.
Yeah,
Yeah. That's
no,
interesting.
they're not.
But can they tell yet that certain exoplanets, if they can find them out there around stars, are they all rotating? Is there such a thing as a planet that just sits still and doesn't
No.
turn at all?
no.
They all got to move, don't they?
I mean, that would be an extreme. That's like balancing a pencil on its point.
Yeah, that's an extreme coincidence, and
Yeah.
that's all it is.
Well, otherwise, some things can get tidally locked and they never move as far as turning. Normally, they're just,
No, when they tidally lock, they turn at the same rate that they rotate
Yeah,
well, that's okay.
or
Like our moon.
revolve.
That's as
yeah, the
close-
moon is tidally locked to the Earth, but if you stand on a place on the moon and survive, you would notice that you have both day and night cycles over 4 weeks.
That's true.
So
But
you
you'll never-
rotate on the moon.
You'll never get much of a tidally locked in an elliptical orbit though, will you?
No,
Sure.
you can.
Really?
Yeah. The moon's in
Okay.
an elliptical orbit.
Well, it comes in faster when it's on the close swing around the
And
other,
that's why we see 60% of it and not just 50%.
but it stays, Mercury's like that, isn't it?
Yeah.
Somewhat tidally locked.
It's it's in a different ratio.
It's in a
Fascinating.
resonance.
Yeah.
3 to 2, yeah.
Yeah.
Well, ladies and gentlemen on the screen, you have dazzled me again, and I don't know how we got through it all, but thank you very much. And let's get ready for what's the thing happening tomorrow night, Chuck?
Oh, it's a school outreach, a science
Oh.
night.
Otherwise, Friday night, 7 o'clock at Westmont.
There's a public telescope night.
I'd
Yeah,
ask
there-
Tom Whittemore, since he's our connection to Westmont, if he's being there, but he's not on the screen anymore.
He'll be there if it's not cloudy. We may have to call it off.
Yeah.
Oh, okay, if it's cloudy. Well, all right, spread the word. We're here and we got lots to talk about and lots to do, and I love it. Thank you. You taught me a lot. We'll do another one. Number 153 is next week when it's the what date will it be? The 23rd or something, I think. Anyway,
22nd.
22nd, yeah.
22nd.
Okay.
22nd.